And today we're going to be talking about inequalities in two triangles. You've got one theorem that applies to this section, and its converse. So the theorem and its converse, it's the hinge theorem. Both the theorem and the converse of the theorem start the same way. So we're gonna say that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent. So this is the beginning of the theorem and the converse of the theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, the first thing that's true, then the longer third side is opposite the larger angle. Converse would be then the larger angle is opposite the longer side. So here's how you'll apply it. Let's say you're given two triangles that look something like this. This angle in here is 90, and this angle is 70. C to D is 10, and C to B is 10. And you're asked to compare AB to AD. So what you've got is two triangles with two congruent sides, because both triangles share this side AC. They're asking you to compare AB, which is this red side, to AD, which is the blue side. And didn't the theorem say that the longer side will be opposite the larger angle? Okay, so what's larger, 90 or 70? 90. So wouldn't side AD be less than side AB? That's the comparison. Identify the side that they're asking you to compare, which was AB to AD, and then just evaluate the angles that are opposite of those sides. The angle opposite the side tells you which side is longer or which side is shorter. Which is just an extension of what we did yesterday.
The opposite of 90 is AB.
Yes, the side opposite of 90 degrees is side AB, and the side opposite of 70 degrees is side AD. The longer side is opposite the larger angle. They'll give you the same type of picture and ask you to compare angles. So let's say you get this picture. MNO, Q. And again, you've got two triangles. And you're asked to compare angle NQO to angle NQM. Some of you have better eyes than others, but to me the easiest way to do this is if I got to compare NQO, I'm going to identify it. It's right here. NQO is this red angle. To NQM, which is the blue angle right above it. I'm comparing red to blue. Here's the blue one. So I've got two triangles with two congruent sides. Alright, they share NQ. So NQ is the same in both triangles, and they both have a side that's 12. So you're going to look at the sides opposite the angles, and that's going to determine which angle is larger or smaller. So in this case, is blue larger or smaller than red?
Smaller.
Blue is smaller than red because the side opposite blue is less than the side opposite of red. So angle NQM is going to be less than angle NQO. That makes sense, right? And that's why they call it the hinge theorem, because they're referring it to the hinge on a door. All right? And if the blue door is opened up 5 feet, okay, and the red door is opened up 6 feet, well, the angle at the hinge is going to be larger at the door that's open 6 feet, isn't it, than the door that's only open 5 feet. The second part of your assignment today, you'll be given two triangles. This angle in one of the triangles is 2x plus 10. This angle is 36. These sides are congruent. This side is 10 and this side is 8. Now the question changes a little bit. Find the range of values for x. Find the range of values for x. The first thing that you're going to determine is which of the two given angles is larger than the other. So is the 2x plus 10 greater than 36 or is it less than 36? It's less than 36 because the side opposite is smaller than the side opposite. So watch, when you're finding a range of values, you got 2x plus 10, and it's got to be less than 36 degrees. But now, 2x plus 10 has to be greater than something. It's an angle in a triangle, so it has to be greater than 0. If you have to fill it in, 0 will always be on the left.
But if they give you something, then
All right, let me show you this. Let's finish this problem first. Let's find the range of values for x. All right, compound inequality, you subtract 10 from each side. You subtract 10 from the middle, from the right, and from the left. So negative 10 is less than 2x, which is less than 26. And then you divide everything by 2, the middle, the right, and the left. So your range of values for x is negative 5 is going to be less than x, which is going to be less than 13. That is your range of values. Now, take a look at this for a second. And let's just say that instead of this being an 8, this is now an 18. Okay? That means now that 2x plus 10 is greater than 36. Right? So if 2x plus 10 is greater than 36, what does it have to be less than? It's got to have there's got to be a bottom of the range and the top of the range. All right, when you're finding the range of values for a variable. What do all of the angles in a triangle have to add up to?
180.
So doesn't one of them have to be less than 180?
Yeah.
All right, so 180 is the top of your range. Okay? If you have to set it up that way, and the angle with the variable in it is greater than the other angle, then the top of your range has to be 180 if you're dealing with triangles. Okay? If the angle with the variable in it is greater than the other angle given, or I'm sorry, is less than the other angle given, it has to be greater than something, doesn't it? And it has to be greater than 0, because you can't have an angle measure in a triangle that's less than 0. Yes?
alright. So the angle with the variable is always in the middle of the two.
Well, I'm getting ready to show you one where it's not. It's hard to say always, and it's hard to say never. You got a question, Jordan?
I got it.
All right, had a girl. All right, so let's look at another one that's sometimes can be a more difficult setup, but I don't know. No. Let's look at this. Right here, two triangles again. we got an x plus 10, 2x minus 5. These sides, AD is congruent to DC. This angle in here is 64 degrees. And this angle is 35 degrees. And again, you're finding the range of values for x. So you've got two triangles with two congruent sides because AD is congruent to DC and they both share side BD. So now, do you see the 2x minus 5? How does it compare to the x plus 10? It's less than. So watch, you got 2x minus 5 is less than x plus 10. Okay? 2x minus 5, this side of this triangle has to be smaller than the side of this triangle. But it's got to be greater than something, doesn't it? It's got to be greater than 0 because you can't have a side length of a triangle equal to a negative. But since you've already got a variable on both sides of this inequality, you can't make it a compound inequality. But what you can say is that 2x minus 5 has got to be greater than 0. Okay? Two separate equations. Remember doing the and the ors? They're both compound inequalities. This is an example of an or compound inequality. So you just have to solve them both. So up top, you would add 5 to each side. 5 is less than 2x, and then divide by 2. So 5 over 2 is less than x. When you solve the other inequality, you would add 5 to each side. So 2x would be less than x plus 15. Subtract x from each side. X would be less than 15. So now you can rewrite this. Do you see how this x, 5 over 2 is less than x. X is less than 15. So 5 over 2 is less than x. And x is less than the 15. So that would be your range of values for x in that example. Just don't try to do this, all right? Don't even write this down, just watch. Just don't try to do this in red. The only way that that inequality works is when the variables are in between the inequalities. It just won't work because if you subtract x here and subtract x here and subtract x here, you're moving the x's from the outside of the right to the outside of the left, and you can't ever solve it. So just write two inequalities. Okay? Yes?
Why did you put the 2x minus 5 up there? 0 is less than that, or greater than that, or less than, yeah. That's better.
Because you can't write a compound inequality that looks like a compound inequality that looks like this.
Yeah, but why did you pick 2x minus 5?
Because that's the side we were dealing with.
Oh, it's the
The 2x minus 5 is less than the x plus 10, but it's got to be greater than something. It's got to be greater than 0. So I had to write a separate equation. Because in this type of inequality, where you've got two inequalities, you can't have a variable in the middle and on the right. You'll never be able to solve it. So you write two inequalities. You see how in this problem, you only had a variable in the middle. And you had constants on the outsides. Then you can write a compound inequality this way. When there's two variables, or there's a variable on either side of the inequality, you have to write two separate ones. Because you're solving for this twice. The 2x minus 5 has got to be solved for twice.
So will always be the one that's less has to be greater.
I can't say always and I can't say never. You just have to read the problem.
Okay.
If this side is less than something that has a variable in it, you got to write two equations. If this side is greater than something that has a variable in it, you got to write two equations. If what you're comparing, if in your range they both have variables, you have to write two equations or two inequalities. If you don't, you'll see why when you try to solve it. You'll come and say, I can't solve this. Every time I move the x, it just ends up somewhere else. So your assignment for today is on page 355. Problems 1 through 6. And then 9 through 14. Do 18 through 23 as well.